We're going to review classifying polynomials. So this is a polynomial, and I want to try to classify it by its degree, its number of terms, and I want to put it in standard form. So the first piece to doing any of those things is breaking this polynomial down into its different terms. Remember, terms are glued together by multiplication, and they're separated by addition and subtraction. So I'm breaking my polynomial into all of its different terms. I'm breaking it at the addition and subtraction. So these are all my different terms of my polynomial. I'm going to go one by one and look at their degree. So I'm first going to look at 5z. To figure out the degree of this, I only care about the exponent of the variable. This monomial has one variable, z, and the exponent is 1. So this has a degree of 1. This term has one variable, z, and the exponent is 3. So this has a degree of 3. This term, the exponent of our only variable is 2. So it has a degree of 2. And this last term, there's only one variable and it has an exponent of 4. So it has a degree of 4. Now I'm only looking at the degrees, and I'm going to ask myself, of these numbers, which is the biggest? That's obviously 4. Since 4 is the biggest degree that I have in this polynomial, the entire thing is a 4th degree polynomial. It's a 4th degree. So the next thing I'm going to ask myself is, how many terms are there? So that's just how many boxes did I make. I made 1, 2, 3, 4. Since this is more than 3, I don't have a more specific name for this than polynomial. So I'm just going to call it a 4th degree polynomial. So now I've classified my polynomial by degree and number of terms. The last thing I want to do is put this into standard form. For that, I also need to look at the degree of each piece. I'm going to put my polynomial in order biggest degree to smallest degree. So I'm just rearranging this so that my degrees go from biggest to smallest. So obviously the biggest number here is 4. We've already said that. So that means when I write this in standard form, the term with the degree of 4 needs to go first. So that's this piece. So I'd have 3z to the 4th. The next biggest number is 3. So that means I need this term that has a degree of 3 next. That would be plus 2z to the 3rd. The next biggest degree is 2, and that belongs to this term. So this term goes next. And the last term we have is 5z. So now I have written my polynomial in standard form. If I wanted to know the leading coefficient of my polynomial, now that it's in standard form, I can just look at the coefficient of the first term. And so in this case, my leading coefficient would be 3. Let's take a look at a different example. So this polynomial is a little bit different because I now have 2 variables in the same term. I'm going to do exactly the same thing that I did in the last example. I'm going to first break this up into its different terms. All of these pieces are being multiplied together, so it's all one term. Here I have a subtraction sign, so that's where I break. That separates my terms. These pieces are all being multiplied together, so it's all one term. I'm going to look at the degree of each term. The degree of this first term is just like finding the degree of any monomial. We need the sum of the exponents of the variables. So I don't care what the exponent of my number is. I only care about the exponents of the variables. Here I have the variables x and y. They each have an exponent of 2. I want the sum of these exponents, so 2 plus 2 gives me a degree of 4. So this term has a degree of 4. This term, I'm only worried about the exponents of the variables. Each of these variables have an exponent of 1. I need the sum of those exponents, so 1 plus 1 gives me a degree of 2. So, of these numbers, the bigger one is 4, so this is a 4th degree polynomial. So right there I've classified it by its degree. And the next thing I'm going to do is classify it by its number of terms. So how many boxes did I make? I made 2 different boxes. Since I have 2 terms, we call this a binomial. So this is a 4th degree binomial. For standard form, I want to make sure that my polynomial is written so my degrees go from greatest to least. And in this case, they're already greatest to least. So I'm going to rewrite the polynomial exactly the way it was given to me, because I was lucky and it was given to me in standard form. If I wanted to know the leading coefficient of this polynomial, you do the same thing as last time. The leading coefficient is the coefficient of the first term when you're in standard form. So here I'm in standard form, this is my first term, this is the coefficient of that term. So my leading coefficient is 2. You can only find a leading coefficient when you're in standard form. If I had written my polynomial like this, -8 would not be my leading coefficient because this is not standard form. So just be careful that when you're looking for a leading coefficient, your polynomial must be in standard form, like mine is here.